Welcome back to the Deep Dive. So today we're getting into something really important for anyone thinking about electric cars or already driving one.
Yeah, that's right, the battery. Specifically, how long does it actually last?
Yeah.
And, how do you take care of it?
Exactly. It's probably the biggest question people have, right? How long will this big, expensive battery realistically keep going? What affects it? And crucially, what can you, the owner, actually do?
Mm-hmm.
So that's our plan for this deep dive. We're going to dig into our sources, go beyond the usual headlines, and really try to give you some clear, useful insights.
Absolutely. Because that battery, it's a big part of the car's cost, so these concerns about lifespan, they're completely understandable.
For sure. And I think sometimes maybe a lack of really clear info can lead to a bit of fear, maybe some misconceptions.
That happens. But, let's start with something people might already get. Like with a regular car engine, these EV batteries, they come with warranties from the manufacturer.
Right, warranties. That's a good starting point.
It is, but it's important to know what these warranties mostly focus on. It's typically about capacity loss.
Capacity loss,
Yeah.
meaning how much driving range you lose over time.
Exactly. It's about that gradual decrease in how much charge the battery can hold. They're not usually there for like a sudden total failure out of the blue.
Okay, that makes sense. And looking at our research, it seems like 8 years is a pretty common warranty period.
Yeah, around 8 years is typical. But here's a key detail, something really worth looking into if you're thinking long-term ownership or resale.
Oh yeah, what's that?
Well, within that 8 years, the manufacturers often guarantee a minimum remaining capacity. Like they promise it won't drop below a certain percentage.
Ah, okay. So they say even after 8 years, it'll still hold at least, say, 70% of its original charge, something like that.
Precisely. And that percentage, it can actually differ between car makers.
Interesting. So that guaranteed minimum, that's something you should really check when buying.
Yeah.
Because it affects the car's value later on.
Definitely. Our sources really emphasize that. It impacts resale value quite a bit. A battery guaranteed to hold more capacity is, well, obviously more attractive secondhand.
Makes total sense. Okay, so you have this warranty. How do you make sure you don't accidentally void it? And more than that, how do you actively look after the battery?
Right. Well, just like with any car, the warranty depends on you using and maintaining the vehicle properly.
So things like missing your scheduled service appointments.
Exactly. Or using parts that aren't approved by the manufacturer, or, maybe using the car in a way it just wasn't designed for. Those kinds of things could potentially put the warranty at risk.
And the battery is, as one source put it, kind of the most precious element of the EV, isn't it?
It really is. It's the heart of the car. And manufacturers, well, they're probably going to look quite closely at the service history if a battery claim comes up down the line.
So due diligence is key, especially if you're buying a used EV. Check those maintenance records thoroughly.
Absolutely. Make sure the previous owner kept up with servicing and really take the time to read the warranty contract itself. Know what's covered, know what isn't, and what your responsibilities are.
Good advice. Okay, let's shift gears a bit. What about practical everyday things? How can you help your battery last longer? We came across this thing called the 2080 rule quite a bit in our research.
Well, yes, the 2080 rule, it's sort of the golden rule of EV battery care, really.
So what is it, basically?
Well, the idea is to try and keep your battery's charge level between about 20% and 80% most of the time.
Meaning try not to let it drop below 20% very often,
Yeah.
and also try not to charge it all the way up to 100% every single time.
Exactly. It's about avoiding spending long periods at those real extremes, very low or very high charge.
And there's a chemical reason for that, right? Something about stress on the battery.
Yeah, basically, staying below 20% for too long can, over time, cause some internal changes, let's say, that aren't ideal. Think of it like stressing the materials. And charging right up to 100% all the time also puts a different kind of stress on the battery components. It can slightly accelerate the natural degradation process.
So it's not like doing it once is a disaster, but doing it constantly isn't the best practice for longevity.
Pretty much. Plus, charging to 100% can sometimes generate a bit more heat, and heat is generally something you want to minimize for battery health.
Right, heat. That leads nicely into another tip we saw. Maybe don't rely on frequent fast charging, especially like back-to-back sessions.
That's related, yes. Fast charging is incredibly convenient, no doubt. But it does generate more heat within the battery cells compared to slower charging.
And that heat, over the long run, can contribute to faster capacity loss.
It can, yeah. Now, manufacturers are working hard on this. Future batteries and better cooling systems will likely handle fast charging much better.
That's good to hear.
But for many current EVs, using fast charging mainly when you really need it rather than every single day might be a bit kinder to the battery long term.
It's encouraging that the tech is improving, though. We saw something really exciting about a prototype battery. From CATL, they work with VW and Tesla, right?
That's right, a huge player.
And that this battery could potentially last over 2 million kilometers. That sounds almost unbelievable.
It's a massive claim, definitely. The innovation there seems to be all about the internal chemistry of materials.
How so?
Well, they've apparently developed things like special coatings for the cathode, which is a key part of the battery. This coating sort of protects it, stops unwanted chemical reactions.
Okay.
And they've also tweaked the electrolyte, that's the liquid or gel inside, that lets the charge move around. They've made it more stable. So these things together drastically slow down the processes that make batteries degrade.
Wow. Okay. So much slower degradation means much longer life. Fascinating stuff.
It really is game-changing potential.
But let's come back to today's reality for a moment. That 8-year warranty runs out eventually. What happens then? People must wonder, what state will my battery be in after 8, 9, 10 years?
It's a fair question. Even with good care, some capacity loss over that time is pretty much expected. It's just the nature of the technology currently.
So the car's range will likely be lower than when it was new.
Yes. Our sources use an example, like a car that started with 500-kilometer range might realistically offer maybe 400-kilometer, perhaps 350 kilometers after that warranty period.
Which for some people might still be perfectly fine,
Right.
especially for city driving or shorter commutes.
Absolutely. If your daily driving doesn't push the limits of the original range, then a reduced range might not be a huge issue. You might just need to charge a bit more often for longer trips.
Okay. And we saw a figure mentioned around 60% remaining capacity as maybe a point where the battery isn't considered ideal for car use anymore.
Yeah, that 60% figure comes up as a sort of rough guide. Below that, the range might become too limiting for practical vehicle use for many people.
But, and this is the really interesting part for me, that doesn't mean the battery is useless, does it? This is where the second life idea comes in.
Exactly. This is a huge area of development and potential. Even when a battery is down to, say, 50 or 60% of its original capacity, it can still store a lot of energy.
Just maybe not enough to power a car efficiently anymore.
Precisely. But it's perfect for other things.
Like what? What are these second life uses?
Well, the big one is stationary energy storage. Think backup power for buildings like a giant UPS system.
Okay.
Or, and this is really exciting, integrating with renewable energy sources. Storing solar power generated during the day to use at night, or smoothing out the power from wind turbines.
Ah, so helping make renewables more reliable.
Exactly. Storage is key to really unlocking the full potential of wind and solar. These old EV batteries could play a massive role.
So people are actually doing this now, using old EV batteries for storage.
It's happening, yes. Maybe not yet on a massive standardized industrial scale everywhere because we haven't had huge numbers of EV batteries retiring yet.
Right, we need more old batteries first.
We need that critical mass. But car manufacturers, who are often legally responsible for the batteries at the end of their life anyway, and lots of energy companies, they're actively building this out. Lots of pilot projects.
Like those electric boats in Paris we read about. Or the Ajax football stadium in Amsterdam.
Yes, the Ajax Stadium is a great example. They use, I think it's nearly 150 old Nissan Leaf batteries.
Wow.
They charge them up with solar panels on the stadium roof, then use that stored energy to power the stadium during peak times, provide backup, and even help stabilize the local grid.
That's brilliant. Real-world circular economy stuff. So what happens to the actual car when its battery gets taken out for this second life? Is the car just scrap?
Not necessarily. The expectation is that a market for replacement batteries will grow.
Ah, okay. So you might be able to buy a used battery or maybe eventually a more affordable new one or even lease one.
Exactly. As battery production scales up and costs come down, those options should become more viable.
So thinking about the whole lifespan then.
Right.
You've got maybe 8, 10 years in the car, then maybe another 10 years or so in a second life application.
Potentially, yes. Some estimates suggest a total useful life of around 20 years could be possible, combining both stages.
That's way longer than most people probably think.
It really reframes the whole longevity discussion.
Yeah.
But even after that second life, there's one more crucial step.
Recycling, right. That always comes up.
Absolutely essential. And the good news is the technology for recycling EV batteries has made huge strides.
How good are we talking?
Well, current processes can potentially recover up to 98% of the valuable materials inside. The metals, the chemicals, the electronic.
98%, that's incredibly high.
It is, and the research goal is pushing towards 100%. It's complex, sure, but it's vital for making electric mobility truly sustainable in the long run. You have to look at the whole life cycle.
And this recycling challenge, it's not just EV batteries, is it?
Mm.
It applies to our phones, laptops, all sorts of things.
Very true. The principles are similar. Our sources mention two main approaches. One is regeneration, kind of refurbishing older battery components.
Okay.
The other is full recycling, breaking the battery down completely and recovering those raw materials like lithium, cobalt, nickel.
Was cost an issue initially? Like, was it cheaper just to mine new materials?
It was, yeah. For a while, recycling was more expensive than using new stuff. But that's changing fast.
Why is that?
Well, the value of those materials, lithium, cobalt especially, has gone up a lot. And there are concerns about future supply. So suddenly, getting them back from old batteries looks very attractive economically.
Makes sense. Supply and demand.
Exactly. So there's tons of research going into making recycling more efficient, even designing batteries from the start to be easier to take apart and recycle.
Smart. Like designing for the end of life.
Precisely. And you see big commitments now, like Volkswagen aiming for a 95% recycling rate for their batteries after their second life. That's closing the loop.
A true circular economy. Okay, that's a lot of ground we've covered. Let's maybe try and quickly recap the key takeaways for everyone listening.
Good idea. So first off, the warranty is typically around 8 years, or a certain mileage. And crucially, most manufacturers guarantee a minimum remaining capacity, often around 70% within that time.
But remember, you need to stick to the maintenance schedule to keep that warranty valid.
Definitely. Then for daily care, that 20-80% charging guideline is your friend. Helps preserve the battery. And remember, extreme temperatures, hot or cold, can affect range temporarily.
Right. And once a battery drops below maybe 60% capacity, it might not be ideal for the car, but that's where its potential second life really begins, usually in stationary energy storage.
Yep. And while the big industrial scale systems for Second Life and recycling are still being fully built out, the work is happening. Major companies are investing heavily.
So recycling and regeneration become key after that second life. The market isn't fully mature yet, but the research is intense.
It's a huge business opportunity, honestly, but also just a necessity for sustainable EVs. And like we said, many manufacturers are already targeting near 100% recycling rates.
So putting it all together, EV batteries last a good while, they have warranties, you can help them last longer with smart habits, they have valuable second lives, and they're becoming highly recyclable.
That sums it up well. Understanding all that definitely helps ease some of those common worries, I think.
Absolutely. It gives you a much fuller picture of the technology and its whole life cycle.
And maybe a final thought for listeners to chew on. Think about how this evolving battery tech, longer life, second uses, better recycling, isn't just about cars. How might it reshape our whole energy system from the grid right down to our homes, especially as we use more renewables?
That's a great point. And maybe look up some of those second life projects like the Ajax Stadium. It really makes you think about where this technology is heading.